All right, so on mirror line, I said the distance will be very important. So the first thing it says grab the image of the figure using the transformation given. We have reflection across the y-axis. Last year in Algebra 1, you guys learned that, well, before, you guys learned that this right here is the y-axis. So I'm going to move everything, in this case, from the left to the right. But distances are very important. I just said that. So if I look at the point R, is one distance from the mirror line. So it's going to be one distance on the other side. So that gives me my point R prime. If I look at the point Q, there's three squares to the mirror line. So it's going to be three squares on the other side. And that gives me my point Q prime. And my point S is technically, we can say zero spaces on the left. So it will be zero spaces on the right, so it stays the same. So any point on the mirror line stays the same. And then when I connect my points, it seems like my picture flipped on the other side. The same thing I can do with question number 2. So it's reflection across the x-axis. So there's my x-axis. So now I'm going to move everything from the top to the bottom. Use distances. Look at Z, one space on the top. So it's going to be one space at the bottom of the line. If I look at my point Y, it's three spaces on top of the line. So it's going to be three spaces at the bottom. X is on the mirror line, so X prime happens to be on the same spot. So whenever we have pictures, we can count the spaces, right? Easy to count. However, sometimes we're not going to have a picture. We're just going to have numbers. We're going to have the coordinates. So there are special rules. There's 4 special rules on reflection. To follow that, let me follow the point Q. I noticed that initially the point Q is -3, 4. Those are the coordinates of Q. But then when I look at Q prime, my coordinates are 3, positive 4.
So it's just changing the coordinates from positive to negative.
Change all of them or just one of them?
The x changes to the opposite of the y stays the same.
Exactly. So the y stays the same, the x changes. So we're going to say reflection across the y-axis, we're going to say xy is going to become -x, positive y. My -x in my rule doesn't mean change it to negative. It just means change the sign. The x changes, but leave the y alone. All right, let's take a look at my second example. Let me follow the point y. Initially was a coordinates -2, positive 3. Looking at my y prime, I have -2, -3. So what happens?
So one side changes.
Only which one?
One side.
The x or the y?
The y changes the x.
So we're going to say x, -y. So only the y changes. All right. That's going to be very, very useful whenever we don't have figures. Because when we have the figure, we can count spaces. But when we only have numbers, we're going to use these rules. Other 2 special cases is across the y equals x line and the y equals -x. Let me draw on these. Last year in Algebra 1, you guys learned how to graph those lines. The y equals x looks like the y equals 1x plus 0. You guys learned the slope-intercept form. So y equals x line is this line. The y equals -x, which I'm going to do in example 4, that is this line, right? Because my slope changes from positive to negative. So let's take a look. I'm going to do spaces as well, but now because my line is diagonal, my spaces, I'm going to count them diagonal. From you to the line, it's only half a space, kind of like half a square. So it's only going to be half on the other side. So that's going to give me my u prime. Same thing with w. It's half a space, so half a space on the other side. I'm going to look at v. I'm going to do 1, 2, 3 spaces. I'm counting diagonal. So it's going to be 3 spaces on the other side. So that gives me my v prime. I connect my points. Seems like my picture flipped. Same thing with my example number 4. I'm going to count the spaces of R, which is 2 spaces. I'm counting diagonal. So it's going to be 2 spaces on the other side. That gives me my R prime. Q is 1, 2, 3 spaces. So it's going to be 1, 2, 3 on the other side. And then S is 1, 2, 3 and a half. So there's my half, and then 1, 2, 3. So that gives me my S prime. I connected, and it seems like it flipped. On pictures, we can count the spaces, but when it's all numbers, we have to come up with special rules. So for y equals x, let me follow the coordinates of v. I notice that on v, my coordinates are -5, 1. On v prime, I get 1, -5. So what happened? They flipped. Xy becomes yx, right? The numbers flipped. Let's take a look at example 4. This case, let me follow the point Q. I notice the coordinates of Q are -2, -4. But when I look at Q prime, I have 4, 2. So what happened? Nice. So they flipped and they changed the signs. So I'm going to say my rule is -y, -x. They flip and change the sign. Remember, my negative on my rules here doesn't mean they become positive. It means they change the sign. Right? Negative became positive, and so on and so forth. Those are the 4 special cases on reflection. When I'm dealing with numbers only, yeah, I'm going to stick to only these 4 special cases. Now, when I'm dealing with pictures, because you can count spaces, I'm not going to limit myself to only these 4. I'm going to do all the reflections. So these 4 are the only special 4 cases. With pictures, I'm going to do other cases as well. It's an example. Let's take a look at this one. Write a rule to describe each transformation. I'm going to follow my point H. I want to get the coordinates of H. I have the coordinates of this one are 3, -2. When I look at H prime, I have -3, -2. So it seems like my only difference is on the X value, the sign change. Which rule is that? Y-axis. So my rule, the way I'm going to do the rule, I'm going to do reflection. Remember how last week we used to do translation? We're dealing with reflections. I'm going to do reflection across y-axis. So that's what I'm going to write. Do not capitalize the y on y-axis, just the r from reflection. Now let's take a look at my example 6. I'm going to follow the point L. My point L, the coordinates are 5, 4. My coordinates of L prime are -3, 4. It seems like my X totally changed, not just changed signs, totally changed. So it's neither of these special 4 cases. Like I said, when I'm doing pictures, I'm not going to limit myself to only those 4. So this is neither of those 4 cases. All right, so the way I'm going to find the mirror line, I'm going to look at the K's, like K and K prime, the points K and K prime, and find a point in the middle. Look at the J's, like J and J prime, and find a point in the middle. Make a line that goes through those 2, and that's your mirror line. So I'm going to call this reflection across X equals 1. That line you guys should have learned in Algebra 1, that's the X equals 1 line. The y-axis is also known as X equals 0, because any point on the line is X equals 0, right? X value is 0. So the y-axis is X equals 0, so 1 to the right should be X equals 1. If I would have gone to the left, it would be X equals negative something. If you're looking at horizontal lines, the x-axis is also known as y equals 0. So if I go above, it would be y equals positive something. If I go below, it's going to be y equals negative something. So those lines you guys should have learned last year in Algebra 1. Any questions?